Lesson 410 is on relating tables, graphs, and equations. And the question is, how can you analyze the relationship between dependent and independent variables using tables, graphs, and equations? Basically, what we're looking at in this lesson, it's just showing different ways that we can display information. So tables, graphs, and equations are different ways of displaying or describing information. So on 239 it says Nancy walks 4 blocks to Maria's house. Together they continue to walk. Walk can be described as n equals m plus 4, where n is the number of blocks Nancy walks and m is the number of blocks Maria walks. Describe how the equation, data table, and graph reflect the walk. So if we look at this, the equation they gave us, we could look at how many blocks each of them has walked. So for example, if Maria has walked 1 block, then Nancy would have walked, just substituting in for that. So if Maria walked 1 block, 1 plus 4, that would be 5. So Nancy walked 5 blocks. Okay, that's how we get the 5 over here. Same idea, Maria walked 2 blocks, that would be 6 for Nancy. And then 3 blocks would be 7. And the difference of that, the reasoning is why it's 4 more is what they talked about at the very beginning, is that they said Nancy walks 4 blocks to Maria's house. So she's walked to Maria's house, and then from there they're walking together. So hopefully that makes sense of why Nancy's always going to have 4 more blocks than Maria. Another way we could represent that is by a graph. So on a graph, usually the graph we have the x-axis goes across, y-axis goes up and down. Sometimes if they use different variables, then we could put different letters there. So technically, even though the book's still calling it x and y, technically, really the x would be like an M and the y would be like an N. Because those are the variables that we're dealing with, okay? And it's probably a good idea when you draw these graphs, if you don't have to put it like in the little bubble thing like the book's doing, but somewhere underneath the x-axis or the m-axis in this case, tell what that means on that axis. So number of blocks Maria walks, and then on that other axis, the y-axis or the n-axis, we could say that's the number of blocks Nancy walks. So the points that they're graphing, basically, if you think about this would being like an x and a y pair, this would be the point 1,5. This would be the point 2,6. This would be the point 3,7. And so when we go to graph those, 1, 5, 2, 6, and 3, 7, we can go for the 1, 5, we can go to 1 on the x and 5 on the y, gets us to 1, 5. For the 2, 6, we can go to 2 for the x and 6 for the y. 3, 7, go to 3 for the x and 7 for the y. So example 1, the Booster Club members want to raise $50 to donate to a local charity. They buy pom-poms for 55 cents each. So kind of some key information here. They want to raise $50, buy pom-poms 55 cents each. How many pom-poms do they need to sell to reach their fundraising goal? Alright, so also if you look over here, some other information that we need is over here as well. So they're selling the pom-poms for $1 each, and they raise 45 cents for each pom-pom they sell. And the reason that's actually something they already kind of told us, I guess, is that they're selling them for $1. They bought them for, it tells us in the problem, they bought them for 55 cents. So if you take $1 minus 55 cents would be 45 cents. So that's how they came up with that number. Okay. They could have just given us this information in the table and not told us, you know, the fact that they're raising 45 cents for each one that they sell. That would be something we would have to kind of figure out ourselves, really. All right, so if they're raising 45 cents for each pom-pom and they want to raise $50, what they're doing in the book here, they're just making some random guesses. So it's 45 cents per pom-pom. So we could say maybe if R is the amount they raise, so R would be equal to 45 cents times however many pom-poms they sell. Does that make sense? And then they're just trying some random numbers. Okay, so there's nothing magical about the numbers they're picking here. They're just guessing numbers. So they're saying, what if we sold 10 pom-poms? So 45 cents times 10, if you work that out, it's $4.50. Okay, that's nowhere near $50. Let's try something a little bit higher. So then they tried 50. So 50, 45 cents times 50 is $22.50. So then maybe they're thinking about, well, that's not even quite half as much, right? So if we double that, that would get us close. 100 would be close to the $50. Let's go a little bit higher. So they did 110 and they got $49.50. And now we are very close. And so one more would take us to $49.95. So we would actually need another one yet. So that'd be 112 total pom-poms that you need. Okay? So that's one thing we could look at. Another thing, the book talks about graphing the ordered pairs. So we could graph those numbers that we came up with and try to look and see, you know, if we have $50, how many pom-poms does that equal to? Sometimes it's a little difficult to tell that from your graph if your graph's not a perfectly straight line, or like in this case, our answer is 112. 112 might be a little bit tricky to tell by looking at your graph. Okay. Step 3, what they're talking about with using an equation. This is actually the most efficient way to find the answer. This is the easiest way to find the answer on this problem, actually. All right. So in this problem, what they did, they took the equation and they said, well, we're trying to raise $50. So let's say my R value is $50. And then we could think about, you know, well, $50 divided by 45 cents. Okay, they're multiplying, so if you divide, that should tell you your answer. Remember, when you divide with decimals, you can't have a decimal on the outside, so move both those over 2 spots, and then you work that out. You'll get a 111, and technically you'll get 111 and 5/45 if you actually divide that out. Okay, 111 and 5/45, and then you can reduce that to 111 and 1/9. As a decimal, it's about 111.11. The 1 just keeps repeating, actually, but you guys don't want to work it out to get a decimal, so let's keep it with something like 111 and 1/9. Obviously, we're not going to sell 1/9 of a pom-pom to somebody, okay? We're not going to take it and tear it apart. So we would actually then have to sell at least 112 pom-poms to raise that $50. Technically, without doing the equation or the graph or any of that stuff, you guys might be able to just come up with this idea that we need to take $50 and divide it by 45 cents. If it doesn't ask you to write an equation or anything, you're welcome to do it that way as well. So example 2, temperature was 6 degrees Celsius at 8 a.m., increased 2 degrees Celsius each hour for 6 hours. And the question is, what was the temperature after 6 hours? So again, there are ways you guys could do this without doing it necessarily the way that the book's doing it. But we're just going to look at what they did here. So they made a table. So they said the temperature depends on the number of hours that pass. So temperature is the dependent variable. And usually when we go to graph something, the dependent variable is what we have as being on our y-axis, okay? Because that's what we want to see a change, and it depends on the other thing. So if no hours have passed, that's our starting temperature, okay? So this shows us what we just talked about in the problem, is that our starting temperature, so after 0 hours, it is 6 degrees Celsius, okay? And then it says it's increasing 2 degrees each hour. So they kind of skipped over something. I would probably go ahead and put something here. Would be that after 1 hour, then it would be $8 degrees because it has risen 2 degrees. The next hour, so after 2 hours, it's going to go up from 8 to 10. We could fill in here in between also. So after 3 hours, it would be up to 12. 4 hours would be 14. 5 hours would be 16. And then 6 hours would be 18. So that would be one way of doing this, making a table and working that out. And then you could graph those. And some of the problems, they might ask you just to graph these, even if you don't have to figure it out. So this is the number of hours. We could put somewhere down here on the x-axis. And then this is our temperature in degrees Celsius. We could actually just put over on the side here next to our y-axis. And then they graphed the points. So this is a point 0, 6, 2, 10, 4, 14, and then 6, 18. And then those dashes just kind of show us what we're looking for off of our graph. After 6 hours, what is the temperature? Well, go up from 6 until you hit the line and then go straight over, and you can see that would take you to 18 degrees. Okay. Another thing we could do looking at this problem would be writing an equation. So for our equation, they've got 6 plus 2n. 6 is representing, that's our starting temperature. And then plus 2n means it's going up 2 degrees each hour. So plus 2 degrees times however many hours we go for here. In this case, once we have that equation, we're trying to find for 6 hours. So 2 times 6 is 12, and then 6 plus 12 is 18, so 18 degrees Celsius. Okay, and again, I know there's ways around this. You guys wouldn't have had to necessarily do it this way, but sometimes they might ask you to do that. Okay, in other words, some of you might have said, well, it's going up 2 degrees an hour, so it's going up 2 degrees an hour for 6 hours, so 6 times 2, that's 12. And then we started at 6 degrees, so 12 plus 6 is 18. All right, so you could argue for that being a simpler way of doing the problem, and I would agree with you. It's just a matter of what all they want you to actually do on the problem. Okay, again, sometimes they might ask for the equation, or they might ask you to graph the equation as well. So on the try it, a company makes decorations for pins. All the supplies cost $5. And the company plans to sell the decorations for $2 a piece. Analyze the relationship between the number of decorations sold and the profit by completing the table and the graph. Use the table and graph to write and solve an equation to find the number of decorations that must be sold for the company to make a $15 profit. So if you think about profit, profit is equal to your income minus your expenses. So in other words, how much money are people giving you versus how much did you have to spend to start out with? Okay? So in this case, we want to think about, and the book's actually telling us over here, profit is going to be our Y, and the decorations sold is going to be our X. So in our equation, if we say profit is income minus expenses, we just said profit is Y on our graph, and it's going to be equal to the income minus the expenses. So if we sell X decorations, the question is, what is our income? And then we can also think about what our expenses are. So the income is that they're selling them $2 a piece, so they're going to make $2 times however many they sell. And we said decorations sold is a X. So 2 times X, $2 times X would be our income, minus, it tells us that all the supplies cost $5. So altogether, expenses would be $5. So Y equals 2X minus 5 would be an equation that we could use for this problem. Okay? A little bit more complex maybe than some that we've done, but with some practice we can get good at doing those. And then on the table, they are wanting us to find if X is 3 is one of the things they want us to do. So if we put a 3 in place of X, 2 times 3 is 6, and then 6 minus 5 is 1. So in other words, if they sold 3 decorations, they would have a profit of $1. Okay? And then we can make up some other numbers. You know, I see a 6 and I see an 8, so maybe I'll try those as well. For the 6, if you put that in the equation, we could do 2 times 6 minus 5, so that'd be 12 minus 5, which would be 7. So 6, they have a profit of $7. And then for 8, 2 times 8 is 16. 16 minus 5 is 11. The deal is we would like to have a profit of $15. So 11 is kind of sort of close, but not quite there yet. So we could graph these points. So 3, 1, 6, 7, and 8, 11. And then if you draw a line through those points, if you draw a straight line, what we're trying to do is get to a profit of $15, which is right at the edge of our graph here. So if you'll notice, if you draw a straight line, it looks like it's going to take us right to the corner there, and then that would be for 10 decorations. We could actually figure that out by using our equation if we wanted to. We want our profit to be $10. We want our profit to be $15, and then we could just guess numbers until we get something that works. Would be one option, and it would be actually if you put a 10 in place of X, you can see that would give you $15 there.